Okay, in this video we're going to talk about the cylindrical shell method. This method is very similar to the disc and washer method, except this is a different way to approach the same type of question. Now, in yesterday's lesson we talked about the disc and washer method, and you have some function f and some function g. Let's just say the function g of x is equal to y equals 0. Okay, you rotate this, you get a cylinder thing that looks like this. Okay, you get something that looks like that. Now, the difference between cylindrical shell and disc and washer method is that the cross sections are not going to be circles anymore. Okay, instead of circles, it's going to be cylinders. Okay, so in cylinders, if you have to open up the cylinder, and which makes it into a rectangle, you have some function. We'll talk about that in a little bit. Okay, so the difference between another difference is that the axis of rotation and the cross sections, instead of being perpendicular, it's going to be parallel. So that means instead of integrating from, if you have rotating the disc and washer method, you have vertical lines for this because it has to be perpendicular to the axis of rotation. Now, the cylindrical shell method is different. Okay, since it's parallel, that means instead of using f and g, okay, we're going to do the top function and the bottom function into, I actually wrote that down. Okay, it's going to be f of y and g of y, because I am integrating with respect to y. So that means it has to be parallel, so it looks like this. That's what you want to think about it as. Now, the way you want to think about this is, in this diagram here, f of y minus g of y, that is going to be my height of my cylinder. So the way you want to think about it is, it kind of looks like this. F and y, okay? F and g over here. Okay, we fold it up together, you get cylinders, okay? So it's called cylindrical shell because it's a bunch of cylinders wrapped on top of each other. So you have a cylinder inside that looks like this. Further inside you have one that's smaller, and then if you move outside you have a bigger and bigger cylinder, depending on what the radius is. Okay. Now, what that essentially means now is you have function f of y and g of y. Okay. So in that case, this part is going to be a to d now. Okay. So if you open up a cylinder, it's going to be a rectangle. And the rectangle here is going to be, this is my top function, this is my bottom function. That's going to be my height. Okay? Now, how do you find the length of this side? If you open this up, this is going to be the circumference. In that case, it's going to be 2 pi r. So it's going to be dependent on the radius. Okay? So in short, the area function that we have to use for this thing is going to be 2 pi radius times my height. Okay, so for this particular question here, let me just stand over here. Particular question over here, we're going to have to, let's just set it up. Okay, so in that case, 2 pi, that's always going to be consistent. Okay, it's always going to be 2 pi because it's a constant. Now, my bounds here is going to be my, since it's parallel, it's going to be my y bounds for this type of question. Okay, so in that case, you end up with from A to D. A to D. Now, what is my height? My height is just going to be f minus g. Okay, f minus g. Now, what is my radius here? Okay, the radius is dependent on how far in you are in this rectangle, in this cylinder. Okay, it could be here, it could be here, it could be here, it could be here. So in that case, that thing is going to vary depending on which part of the radius you're talking about. Okay, so in this situation, axis of rotation, the width here, that's the maximum radius. And this is the minimum radius. In that case, it's going to be from 0 to 1. So that means my radius will be dependent on my variable of integration. So that means my variable of integration for this particular question is going to be y. Okay, dy. So that here is the example for this type of question, for if you integrate with respect to y. Now, if I do this in terms of my x, you have 2 pi and you have a to b f minus g x dx. Okay, so that's number one. This fits this example. But if you're rotating around this axis, my y-axis, it will follow this type of function. Okay? So, example number one. My function is y is equal to 2 minus x over 2, and y equals 1. And x is between 0 and 1. So I already drew up the diagram over here. Okay? So like I mentioned, the axis of rotation and the cross sections are parallel to each other. So since it's my axis of rotation is the x-axis, that means my cross-section is going to be parallel to that. So that means I have to integrate this function with respect to y. Now, let's set it up. Okay? The volume here is equal to, I don't know what this is doing here. The volume here, well, let's talk about the area. The area here is equal to 2 pi times my radius. Okay, my radius, since I'm integrating with respect to y. Okay, so my radius is just going to be y. And my top function, my bottom function, this is my top, this is my bottom. So in that case, this is f and this is g. Okay, in that case, you have 2 minus x over 2 minus 1. Okay, so that's my top function, this is my bottom function. Okay, so let me change this up a bit. So this is f of y, and my g of y is just going to be 0. Okay, g of y is going to be over here. In that case, no, I messed up. I am integrating with respect to y. Okay, so it's going to be this part minus this part. So my top function is going to have to be rewritten in terms of x. So that means y minus 2, actually write it this way. X over 2 is equal to 2 minus y. X is equal to 4 minus 2y. So I mean you have 4 minus 2y minus 0, and that would be my area. Okay? So this part here, it's just rewriting that one. So x over 2 is equal to 2 minus y. X is equal to 4 minus 2y. Okay, so that's my top function. My bottom function is 0, so in that case that's my area function. So that means my volume here is equal to 2 pi integral between my bounds of y is 1 to 2, y times 4 minus 2y dy. Okay, so that will be the answer to this question will be that. And all you have to do is go ahead and integrate that and you will get the answer that you need. Okay, so let me rewrite that, move it over so I have space. So the area here is equal to 2 pi y 4 minus 2y. Okay. Now, if I rotate around the y-axis here, my cross-section is going to be parallel to that. Okay, it's going to be vertical. That means I have to integrate this function with respect to x. So that means my area function a is equal to 2 pi times my radius. Okay, my radius in this case is just going to be dependent on how far I am in here. Okay, so in that case, at 0, my radius is 0. Okay, at 1, my radius is 1. Okay, so that means it's going to be dependent on my axis of rotation. Not my axis of rotation. It's going to be dependent on x, which is, again, parallel to the axis of my rotation. And then my top function minus my bottom function. My top function is given by 2 minus x over 2, and my bottom function is 1. In that case, you have 2 minus x over 2 and minus 1. Okay, so you have that. Okay, let me just make it clear here. This is my top function, and this is my bottom function. Okay? So that means my volume here, the volume is equal to 2 pi integral between, since I'm integrating with respect to x, from 0 to 2. Okay? Oh, should be 2. My bad. Okay? So in that case, I end up with having 2 minus x over 2 minus 1 times my variable of x times my variable of integration dx. Okay, so that means that these are my answers here. Okay, so sorry about that. Okay, just make sure you make that change. Now, when we have a shifted axis of rotation, so that means we shift it down or shift it up, shift it left or shift it right, we can also apply this to the shell method. Okay, so if I give a random function, f of x and g of x, I'm rotating around y is equal to negative c, that means my axis of rotation at the bottom. Okay, so what that essentially means is that we just have to write my function dependent on my radius. Okay, my radius would change, and that's the only thing that would change. Okay, so my rotation is here, so that means my axis of rotation is horizontal. That means my cross section is going to be horizontal as well. Okay, so let's go and do that. Okay, so now what that means is we have to change this in terms of x, f of y and x. And this is going to be, you're going to have to integrate this with respect to y now. Okay, so let me change this up a bit so I got this wrong. Okay. So here we have the top function is f of y and g of x. F of y, oops. And let's just go to this one first. So that means my volume here, my area, okay, my area is going to be 2 pi times my height, so that f minus g, so in that case f minus g. Okay, now my radius is dependent on, again, how far I am away from my axis of rotation. So in that case, this biggest part is going to be the distance of my y to my axis of rotation, c, negative c. So that, what that means is that my radius here is going to be the distance. In that case, it's going to be, since it's integrated with respect to y, it's the distance, how wide this is. In that case, it's going to be y minus c. In that case, it's y plus c. So that means my area, my volume here will be given by v is equal to 2 pi between a to d of f minus g, so f of y minus g of y times my radius. My radius here is equal to y plus c dy. So that's the answer to that one. Now, likewise to this type of question, so this is a to d. My cross sections are parallel to the axis of rotation, so it's going to be horizontal again. Okay, so that means my area here is going to be A is equal to 2 pi times my height in this case is going to be how wide this is. Okay, so that's going to be, again, f minus g. So this is f and this is g. Okay, and then my radius is, again, how far away from my axis of rotation is. In that case, from 0 to y, from 0 to c, that's how far it is, and then from dependent on that. So in that case, it's going to be, c is a bigger number, so c minus ym, c minus y. Okay, so because this is, as you go up, you're getting closer and closer. That means this number is going to get smaller and smaller, which kind of fits our narrative. So that means my volume here is equal to 2 pi, and then between a to d. Okay, my functions are f minus g, and then I have c minus y dy. Okay. Now, next example, rotate around x equals negative c, so it's on the left side of my function. So on the y-axis, so that means, again, since I'm doing that way, this A and B, A and B. So my rotation, my cross sections are going to be parallel. So that's going to be like that. So that means I'm integrating with respect to x. So that means my area function a of x, a is equal to 2 pi times the top function f and g, top function, so f minus g, okay? And then my radius is how far away from I am from my axis of rotation. So this is the furthest away, this is how close I am. So at x equals 0, I am c distance away. And at this distance, I am going to be c from where I am, this point here to this. Yeah, that's going to be whatever that width is. So in that case, it's going to be x plus c. Okay, so that means my volume here is 2 pi, integral from a to b. Okay, f minus g, and then I have x plus c dx. Okay, now when you shift the axis of rotation to the right further, in that case you end up with x equals c. Again, first of all, my cross section is going to be parallel, so in that case it's going to be in terms of x. Okay, so that distance and this distance, how far away I am from the axis of rotation will be how large my radius is. So in that case, my area function a is equal to 2 pi times my function, the top minus the bottom, that's my height. In that case, you have f minus g, f, g. And again, how far away from I am. So in that case, at x equals, when x equals at a, my distance is so wide, very wide, and at x equals b, I'm very close. So in that case, you want to show that in your radius. In that case, it's going to be c minus x. Okay? So that means my volume here, volume is equal to 2 pi integral from a to b. Again, integrating with respect to x. And then I have my function f minus g, and then I have c minus x dx. Okay? So that's basically it. Okay? So takeaway message for this is that the cross sections are no longer perpendicular to the axis of rotation, but the cross sections are going to be parallel. That's number one. Number two is that the cross sections are no longer circle; they are rectangles. In terms of in the way that it just looks like, well, cylinders, but then you make it look like a rectangle by opening it up. Okay. So the other thing is everything else stays pretty similar to the discount washer method, except the difference is that you're only changing the radius. The height will never change. It's going to be f minus g, and my radius will be dependent on how far away I am from the axis of rotation, and that's my radius. Okay. So in the next video, we're going to do a couple examples, and I'll see you in the next one.